In this video, I'll discuss how to evaluate limits by substitution. Our examples will involve polynomial functions, rational functions, and some other functions involving radicals. Okay, so example number 1, we have the limit as x approaches 2 of negative x squared plus 5x minus 2. For polynomial functions like this, you can just directly substitute the given index, the small number under the limit symbol or notation. Okay, so we have this limit is equal to the negative of 2 squared plus 5 times 2 minus 2. Now take note that for the first term, it's only the number 2 which has an exponent of 2, not negative 2, right? So this is the same as the negative of 4 plus 10 minus 2, which is equal to negative 6 plus 10, which is equal to positive 4. So this is now the required limit. Let's have example number 2. We have the limit of 8 times the quantity t minus 5 times the quantity t minus 7 as t approaches 6. This is similar to example number 1. We can just directly substitute 6. So this is 8 times 6 minus 5 times 6 minus 7, which is equal to 8 times 1 times negative 1. So the final answer here is negative 8. Alright, so let's have the third example. Now we have a rational function. For rational functions, we have to check whether after substitution we have a 0 over 0. So if that's the case, then we must try factoring the numerator and the denominator and then cancel out common factors. Obviously, in this example, if you substitute 2, you will not have a 0 over 0. Okay, so we don't have to try another method to simplify the rational function. So this one is equal to 2 times 2 plus 5 divided by 11 minus 2 raised to 3. So we have 4 plus 5 over 11 minus 8. So this is equal to 9 divided by 3. So the final answer here is 3. Alright, so we have now example number 4. Okay, so this one is different from the first 3 examples because this now involves radical. Okay, so what can we do now? Again, you have to check whether we produce a 0 over 0 or a 0 at the bottom. Okay, so if we substitute 0, obviously the denominator does not become 0, right? So this one is just equal to 3 over the square root of 3 times 0 plus 1, which is equal to 3 over the square root of 1 plus 1, which is equal to 3 over 1 plus 1. And so the final answer is 3 over 2. Alright, now let's proceed to example number 5. This is similar to example 4, but let's just check whether we will produce a 0 over 0. Okay, so I'll just show you how to check that. We'll just substitute 0 for h. So let's have let's write first the expression here. 5h plus 4 minus 2 divided by h. Now if we substitute 0, we will have the square root of 5 times 0 plus 4 minus 2 over 0. So this is the square root of 4 minus 2 over 0. And take note, square root of 4 is 2, and 2 minus 2 is 0. So we have 0 over 0. So this one is an indicator that we have to try doing something else to the numerator and denominator and cancel some common factors. So how do we do that? If for cases like this, a case that involves radicals, try to rationalize either the numerator and denominator depending on where the radical is located. So in this case, the radical is in the numerator, so we have to try to rationalize the numerator. So how do we do that? We use the conjugate of the numerator. Since the sign here is negative, we have to multiply the numerator by square root of 5h plus 4 plus 2, and also multiply the denominator by the same expression. So we have the limit as h approaches a 0 of the square root of 5h plus 4 minus 2 over h times the square root of 5h plus 4 plus 2 over the square root of 5h plus 4 plus 2. Now again, so if here the sign is negative, so the conjugate is a positive here, right? But if the given is a positive, then the conjugate, the sign in the conjugate must be negative. Okay, so what's the logic behind this? Actually, this is an application of the difference of squares. Take note that the difference of squares, if you can recall, is a squared minus b squared is equal to a plus b times a minus b. So imagine this to be our a minus b, this one a plus b. So if we multiply these two expressions, then we can cancel out the radical symbol. We can get rid of the radical symbol rather, and then get rid of some constants and hopefully cancel some common factors in the numerator and the denominator. Okay, so I'll just show that. So applying the difference of squares, we have the square of the square root of 5h plus 4 minus the square of 2. Okay, so in the denominator we have h times the square root of 5h plus 4 plus 2. Alright, so we have in the numerator we have the limit. We have the limit as h approaches 0. The numerator now becomes the square, 5h plus 4, right? So 5h plus 4 minus 4 over h times the square root of 5h plus 4 plus 2. Now we cancel 4, right? So we have now the limit as h approaches 0 of 5h over the expression h times the square root of 5h plus 4 plus 2. Now notice that we can cancel h. So we have the limit as h approaches 0 of the expression 5 over the square root of 5h plus 4 plus 2. Now we can substitute. Notice that if we substitute, we get 5 over the square root of 5 times 0 plus 4 plus 2. So we have 5 over the square root of 4 plus 2, and so we have 5 over 2 plus 2. The final answer now is 5 over 4. Alright? Okay, so we have example number 6. Example 6, we have the limit as x approaches negative 5 of x squared plus 3x minus 10 over x plus 5. Again, you check if the given is a rational function, you check whether after substituting the index you produce a 0 over 0. And obviously this one produces a 0 over 0, so we have to try to factor the numerator. So I'll just check that one. I'll not show that because in example 5 I have already shown how to check the whether you produce a 0 over 0. Okay, so this one is equal to this one is equal to the limit as x approaches negative 5 of, so the numerator is the same as x minus 2 times x plus 5, right, over x plus 5. So we can just cancel out x plus 5. So we have the limit as x approaches negative 5 as x minus 2. Substitute now. We have negative 5 minus 2. So the answer now is negative 7. Another example, maybe the last example. We have the limit as t approaches negative 1 of t squared plus 3t plus 2 divided by t squared minus t minus 2. Again, try to check whether it produces a 0 over 0. In this case, obviously it will produce a 0 over 0. So I leave the exercise of checking that one to you, okay, since I've already shown this one in the previous example. So how do we factor this? The numerator is the same as t plus 1 times t plus 2. The denominator, on the other hand, is the same as t plus 1 times t minus 2. Now we can cancel t plus 1. So the given limit is equivalent to the limit as t approaches negative 1 of t plus 2 over t minus 2. Now we can substitute. So we have negative 1 plus 2 divided by negative 1 minus 2. So the final answer now is positive 1 over negative 3, or negative 1/3.